Welcome to our video lesson. You should be watching this on Friday in class. It's all about finding the greatest common factor. To start, please turn to your learning goal sheet. Our learning goal today is learning goal number 7, to find the GCF, or the greatest common factor, of two whole numbers that are less than or equal to 100. Please fill in the missing words. Then, think about your level of understanding. I know you've found the GCF before. Think either I'm at a 0, I know nothing, 1, I've heard it before, 2, I know a little bit about it, 3, I know something about it, 4, I know how to do it, or a 5, I am ready to teach it. And put your level of understanding over there, circle it please. When you've done that, you need to turn to page 21 in your math notebook. There you should have glued in our guided note for today. Please make sure you fill it in as we go. Alright, let's get started. Before we can talk about finding the greatest common factor, we need to talk about what it means. Common is another way of saying shared. So in other words, a common factor is a shared factor, or a factor that two or more numbers share or have in common. Now, what's a factor? A factor is a number that is multiplied with another number to give the product. So in this case, 5 and 4 are factors of 20. When we're looking to find the greatest common factor, we're looking to find the largest shared factor of two numbers, or the greatest factor that two or more numbers share. You can do it with more than two numbers, and we will do one example with 3 numbers. Once you've got all this filled in, feel free to move on to the next slide. The first method we're going to do is the listing factors method. The first thing you need to do is fill in our steps. So our first step is to list the factors, or numbers that can be multiplied with other numbers to make our product, or our number we're using. The second thing is to circle the shared factors. And the last one, the biggest one, is the GCF. Alright, let's start with the number 80. For the listing factors method, we're going to use our divisibility rules. So here we have the number 80. Well, we know all numbers are divisible by 1. So we're going to start with 1. What multiplied by 1 gives 80? 80. 80 multiplied by 1 gives 80. Alright, now let's think about the number 2. 80 is an even number because it ends in a 0, which is an even number. So we know it can be multiplied by 2. What's 80 divided by 2? Well, we can do that in our head. 80 divided by 2 gives us 40. Alright, is it divisible by 3? What's 8 plus 0? It's 8. Is 8 divisible by 3? No, 8 can't be divided by 3 without a remainder, so we know it's not divisible by 3. Okay, is it divisible by 4? Yes, 80 is divisible by 4. It's divisible 20 times. Next, is it divisible by 5? Yes, all numbers that end in a 0 or a 5 are divisible by 5. Let's do the work over here to see how many times 5 goes into 80. 5 times 1, or 5 goes into 8 1 times, and 1 times 5 is 5. We subtract that and get a 3, bring down that 0. 5 goes into 30 6 times. 6 times 5 is 30. And we subtract that to get a remainder of 0. So that means that 5 times 16 gives us 80. Alright, what about 6? The divisibility rule for 6 is if it's divisible by 2 and by 3, then it can be divided by 6. But in this case, it's not divisible by 3, so it can't be divisible by 6. It's not divisible by 7. What about 8? Is it divisible by 8? Yes, it is divisible by 8. 8 times 10, if I can squeeze that in there, gives 80. And now we know we're done. Once you reach 10, you're done. Move on to the next number. Okay, 64. Again, we're going to start with 1. Everything is divisible by 1 and itself. Now, is it divisible by 2? Yes, it is divisible by 2 because it's an even number. What times 2 will give us 64? If you want to, you could do that division down here on the side to check. But I'm going to do it in my head, and I know that it's 32. Alright, the next one is 3. For 3, we need to add 6 plus 4 together. That gives us 10. Is 10 divisible by 3 without a remainder? No. So we know it's not divisible by 3. What about 4? I have a feeling that it is divisible by 4, so let's check it out. I'm going to do the work over here. 4 can go into 6 once. 1 times 4 is 4. And 6 minus 4 is 2. Now bring down that 4. How many times does 4 go into 24? It goes in 6 times. 6 times 4 is 24. And we'll subtract that and get a 0. So that means that 4 and 16 are both factors of 64. Now let's do 5. Does it end in a 0 or a 5? So no, it doesn't. So no, it's not divisible by 5. Now 6. Can it be divided by 2? Yes. But can it be divided by 3? No. So it's not divisible by 6. This isn't divisible by 7, but it is divisible by 8. And 8 times itself would give us 64. Now is it divisible by 9? 6 plus 4 give us 10. And 10 isn't divisible by 9, so it's not divisible by 9. And our last one, 10, it doesn't end in a 0, so 64 is not divisible by 10. Okay, so we've listed all our factors. Step 1 is done. Now we need to circle the shared factors. I'm going to do that in a different color. Any ones that they have in common, they both share 1, they both share 2, they both have 4s, they both have 8s, they both have 16s, and that's it. So we've done this step. The biggest one is the GCF. So that means the GCF of 80 and 64 is equal to 16. Now, some of you might find this method easier, but some of you might find it very confusing because you have to use your divisibility rules. If you like this method, that's great, and you are welcome to use this method. If you don't like this method, don't worry, there's a different option out there for you. Method 2 is using factor trees. It's actually the method I like better, but you are welcome to do either one. First, please make sure you write down your steps. Our first step is to write a factor tree for each number. It's just like what we did yesterday. Then we need to circle the last number in each tree, write the prime factorization, which we did yesterday as well, and circle the common factors. Then multiply the factors together to get the GCF. It sounds confusing, but hopefully once we get started, it will be fairly straightforward. Okay, first step is to write a factor tree for each number. Our first number here is 28. What can we divide 28 by? Well, I think of 2 right away, and I know that 2 times 14 gives 28. Now I need to stop and see if either of these are prime numbers. 2 is a prime number, so I'm circling it, but 14 isn't prime, so I'm going to keep going. What can be multiplied together to give us 14? Well, I think 2 and 7. So I'm going to now check and see if those numbers are prime. 2 is prime, so I'll circle it, and 7 is also prime, so I'll circle it. Now that my factor tree has all circles at the end, I know I am done. Now I can do 42. 42 is, when I think of 42, I think it's divisible by 7 and 6. Now 7 is a prime number, so I circle it, and that leg is dead. But 6 isn't prime. 6 can be multiplied by 2 and 3. And I'm going to circle both 2 and 3 because they're both prime numbers. So we've made a factor tree for each one, and we've circled the last number in each factor tree. Now we need to write their prime factorizations. 28 is equal to 2 times 2 times 7. I'm just taking the last numbers down here and writing them down below. Now the same thing with 42. 42 is equal to 2 times 3 times 7. Now I've written their prime factorizations. Now I'm going to circle the common factors they have. So they both have the 2's, and they both have 7's. So I've done step 4. Last step, step number 5. I need to multiply the common factors together to get the GCF. So in this case, one common factor is the 2. And the next one is the 7, so I'm going to write 2 times 7. So their greatest common factor is 14. We're going to do another example, don't worry. This one is 115 and 21. All right, 115. I know that's divisible by 5 because it ends in a 5. So I'm going to write my 5 here, but I don't know how many times it will go into 115. So I'm going to do my division off on the side here. 115, sorry, how many times can 5 go into 1? It can't. So how many times can 5 go into 11? It goes in twice, and 2 times 5 is 10. Subtraction, get a 1, and bring down that 5. How many times can 5 go into 15? It's 3 times, and 3 times 5 is 15. We subtract them and get a 0. So we have over here 5 and 23. Now are they prime? 5 is a prime number, and you know what? 23 actually is 2, so I'm going to circle them both, and my factor tree is done. Now it's time to do 21. When I see 21, I think of 3 and 7 as my factors, and 3 is prime, and 7 is also prime. So you know what? That means that factor tree is done as well. The next step is to write out our prime factorization. So we have 115, and that is equal to 5 times 23. Then we have 21 over here, which is equal to 3 times 7. The next step is to circle the shared factors. But these two don't have any shared factors. We have 5 and 3, and 23 and 7. Nothing lines up. So this means when you don't have any shared factors, there's always one that they have in common. If you don't see any shared ones, that means our GCF is 1. Can you write this down, please? If two numbers don't have a common factor, their GCF is equal to 1. I have to write the 1 over there because there's something blocking me. So if any two numbers don't share a GCF, their greatest common, if any two numbers don't have a common factor when you use their factor trees, their GCF is always 1. All right, one last example. Now this one's a little bit different. It's different because we have 3 numbers, but it's exactly the same steps. We are going to start by making a factor tree for each number. I suggest you pause the video and try this on your own because we've done this several times. So we're finding the GCF of 30, 12, and 15. 30, the two factors that multiply together to give me 30 that I think of right away are 3 and 10. 3 is a prime number, so I circle it, and then I look at 10. 10, two factors that make 10 are 2 and 5, which are both prime numbers, so I'm going to circle both of them, and I'm done. Then, for 12, the numbers I think of are 3 and 4. If you think of other numbers, that's just fine. 3 is a prime number, so I'm going to circle it, and 4 can be broken down into 2 2s, which are both prime. Now 15. 15 can be factored into 3 and a 5, and I circle both of them because they're both prime, and that's it. Now I need to write their prime factorizations, 12, 15, and 30. 12 is equal to 2 times 2 times 3. 15 is equal to 3 times 5, and 30 is equal to 2 times 3 times 5. Okay, now I need to circle their common factors. Well, first, 2 of them have 2's, but they don't all have 2's. They all have a 3, but they don't all have a 5. So the GCF of these 3 numbers is 3. Those are all the examples I have for you. I hope it's going well. Now you need to work on the IXL and make sure you show your work in your notebook. That's all for now, and I'll talk to you later.